Good morning, good evening, or good afternoon, wherever you happen to be in the world. I hope you're having a beautiful day. This is Captain Coda. We're back. Day 8. We've made it. We've made it a whole week. We've got 14 beautiful gold stars. Trying to save Christmas over here. One day at a time. Get a little worn down with these. I've been putting together tutorial videos. Yesterday, at least, that was a long one. That video editing took a long time to get done, but we did it. We did it. My students will be happy for it. I'm very tired this morning. Very tired. Not necessarily from putting that video together, just very tired. I'm feeling worn down. Just in general, a lot going on. These puzzles, they don't stop. They just keep on coming. Keep on coming, and I'm okay with that. Let's take a look at today's puzzle. I've pulled it up here. I don't know what it is. I don't know what it is yet, except that it's called Treetop Treehouse, and I see a grid of numbers. I know we're gonna have to do something with a grid of numbers. So let's read through it. I apologize for my voice if it's a little raspy, or if I'm clearing my throat, I apologize ahead of time. You guys get to hear me first thing in the morning. These are the first words I've spoken since I went to bed last night. The expedition comes across a peculiar patch of tall trees, all planted carefully in a grid. The elves explain that a previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a treehouse. First, determine whether there is enough tree cover here to keep a tree house hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. Okay. The elves have already launched a quadcopter, to generate a map with the height of each tree, your puzzle input. All right, so we're gonna get the height of our trees. What's a quadcopter? Ooh, it's like a drone. I want a personal, they have these personal flight drones now. They're only $100,000 and they can only go for about 20 minutes. Definitely seems like a reasonable personal purchase, right? I want a quadcopter. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the other trees between it and in edge of the grid are shorter than it. All right, so a tree is visible if it's tall enough that it can be seen from any side. So it needs to be the tallest tree in all the trees to one direction must be shorter than it. Yeah. Only consider trees in the same row or column. That is, only look up, down, left, or right from any given tree. No diagonals, only orthogonal directions. All of the trees around the edge of the grid are visible since they are already on the edge. There are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. The top left is visible from the left and top. Yep, the 5s block it. The top middle is visible from the top and right. The top middle 5. Yep, visible from the top and to the right. The top right 1 is not visible from any direction because it's surrounded by all numbers greater than it. The left middle 5. See, it's gonna say it's visible from the right, only from the right. Okay, the center 3 is not visible from any direction. For it to be visible, there would need to be only trees of at most 2 height between it and some edge. The right middle 3 is visible from the right edge, but it's blocked by a 7, blocked by a 9, blocked by a 3. Okay, I think I get it. I think I understand our input. What do we need to produce? With 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. Consider your map How many trees are visible from outside the grid? Okay, so we need to calculate. So there's like a super naive version of this that probably is too slow. There's a super naive version where we examine each tree individually. We say, hey, am I visible? Look in all directions, say, hey, am I visible? This is like what would that be? Like an n squared, n cubed. It'd be pretty gnarly runtime for a big input. I imagine our input's pretty big. Not crazy big. It's big, not crazy big. So the second naive solution that I'm going to, this is what I'm going to do the first time. I bet there's some cool solution where you just basically build up like a histogram or something as you go. My solution is still going to be O of n. So I'm only going to read each number a constant number of times. My goal is I'm going to load everything into an array. Might not even need to do that, but I think I'm going to go ahead and convert everything to integers. Then I'm going to just sort of go across every row, left, right, up, and down, and basically mark trees. I'll keep a second array where I mark trees that are in there. I'll probably just use a dictionary to make my life easier. Yeah. So I think that's approach much. I actually don't know if this is easier than yesterday's problem, but I'm gonna be writing a lot less code, I think, assuming I understand the problem. I think I'm gonna be writing a lot less code. So let's get a string in here. String array rows equals file.readAllLines example.txt. Smab, so nice to see you this morning. Let me get my chat on the screen so it doesn't look like I'm just talking to myself. Happy Thursday, my friend. This looks like a fun puzzle to optimize, to try and find a really optimal solution. I'm gonna do something naive, not super naive, but something relatively naive where I just sort of go each direction. So it's still an O of n, but my constant is like 5 or 6, something like that. Let me get an example here. Example.txt. Did you get some sleep? Let me ask you that. I know you were saying that you had not slept too well or not had enough sleep in the last couple days. I hope you got some sleep. I am feeling tired today. I went to bed crazy early too. I fell asleep. It's probably because I fell asleep on the couch. Gotcha. I think there's there's a fine line. So my solution is still going to be O of n, which I think is fine. Or at least my thought, assuming I get my solution correct. Oof, you gotta get that sleep in. I slept. I don't think I know I kept waking up, but I fell asleep on the couch. If I had slept all through the night, let's say I went to bed at I think I was asleep for at least 8 or 9 hours, but I know I was up in between. Keith, happy Thursday. Good to see you. So we're gonna load this into an array. So I wanna do this. Get height. Oh! I'm gonna try not to upset Keith here. We're just gonna call this height map. And it's gonna take in our rows like this. I almost wrote get height map. My Java is showing. My Java is showing a little bit. I gotta get better at that. My inclination, I'm touching my face, which people have told me is gross. I gotta stop doing that. In the morning, I'm rubbing the sleep out of my eyes. Okay. I know it's gonna be square. Do we know it's square? I don't know if it's square. Well, we're about to find out. think, yeah, I'm not sure if a linky solution is, I don't know, maybe. Maybe. We'll get our height map though. For int row is less than rows dot length row plus plus, and then for int column equals 0, column less than we'll do char. Well, I still want it to be a string. All right, we'll do this. Row of length, column plus plus. Yeah. This is like a more discrete mathy puzzle than, or at least the way I'm solving it, than yesterday's puzzle. Yesterday's puzzle was like a fun way to engineer something. I don't really feel like building up like some kind of cool model for this one. This one feels straightforward. Let's initialize this ahead of time. Int array height map equals new int array, and I think it's square, but I'm not sure. I'm actually not sure if it's square. I'm hoping it's square. We'll find out. Rows.length. Rows.length. Is that how we do that? Boom. That's how we do that. I could always do pairs, index of pairs, which I've done before. All right, so we are going to say that our height map at our row and our column is equal to our rows at row at column, and then we're gonna return height map, but we also gotta parse that into an int.parse. Let's be gross. I just, I want to maybe I don't need to make a height map here, but I want it to sort of be a height map. I want an array of ints, and I need to know the size ahead of time. So at least if I declare it this way, I need to know the size ahead of time. Like I said, I could do it as pairs, and then I don't need to know. Okay, so let's make sure that this height map rows int array equals my height map. Let's run that real quick. See if I get some index out of rounds. I don't, and I, just for, yeah. Okay, so I know it's square, or I'm 90% sure it's square. I should print it out, right, just to make sure. Let me make sure I'm not, yeah, I'm just gonna real quick print it out. Or I might want to print it out later, I don't know. Let's write a function, void print height map, map. It's probably a nice way to print this too. Let's do this becomes map dot. See, Keith, they use get length here. Why is this one called get length? Map.getLength 0. We'll toss that in here. My brain's not working this morning. I can tell my brain is running slow, but the height and width, you could use the width in the column for the loop. My brain just doesn't want to work right now. console.write map row column console.writeLine. All right, let's just make sure. Yeah, I should probably just have a nice grid helper function, right? So I'm sure there's more maps coming. Yeah, that looks good. All right, I just wanted to make sure, let's make sure my whole puzzle input here is also a grid input.txt. From .NET 1, that's fine. I'm mostly just giving you a hard time. I also know Unity has a bunch of get methods, and so that, not that I do a ton of programming in Unity, but I'm teaching a Unity class. Okay, all right. All right, I have confidence here that it is in fact a square. All right, so, I'm just gonna do I was gonna do a bool array with matching indices, but I actually think I'm gonna do a dictionary from row columns to, oh no, I'm gonna just do a set, hash set, int visibles, visible trees. I have some and used one today, but I really need to go back and look at the helpers. I created a bunch for last year. I only like get when something is doing something like cross a process boundary and might fail while getting. That's a good point. I really like in C#, I love the try method. So try parse. I like the ones that is like, here, I'm gonna try something, I'm gonna tell you, I'm gonna report back whether it did it. Java went super extreme. Everything has get in front, and I programmed in Java essentially professionally. I worked at a company for 6 years, I think, where we programmed in Java. It's like Java 1.6. We had our own, I worked on, we had our own custom Java compiler, so I was working in bytecode land, Java bytecode land, for many years. But yeah. Okay. Print height map. We want to, the idea I have is I'm just going to do all four directions. I'm going to do every row from left to right, every row. I'm going to go right, go left, go up, and go down. And just find and check as I go. Be like, is anything bigger to my left? Yeah. So the goal here, go left to right, go right to left, go top to bottom, go bottom to top. So not the most efficient, but it's still O of n. My constant just happens to be I'm looping a bunch. It's just like 4 or 5. So big constant, maybe not even big, feels big to me. For int row, so we're gonna do every row. Oh, I'm hating how many times I'm writing this here. I should abstract that, right? I should write a function that tells me that processes rows and processes columns. All right, it's okay. Int row equals 0, row less than I'm gonna make a variable called size. Int size equals height map dot get length 0. Size row plus plus for int column equals 0. Row is column less than size. Column plus plus Yeah, so this one, it's like, the approach seems so straightforward that I'm like, I don't really feel like spending the time doing this thing once. But yeah, I could make something that's like, okay, generate pair generator and like do something interesting with that, but I'm not gonna do that. So left to right, right to left. All right, so this is left to right. Int max or tallest equals do you need to start at 0 and end at size since outermost trees are always visible? Technically no. Technically no. Great point. I'm gonna try and guess how you pronounce that there. Case knock, quiz knock. Let me know how you pronounce it. Saw someone's height map using color gradients. That was cool. Yeah. So yeah, you're technically right. I don't have to go all the way to the end because the outside's always visible. Not like in Spanish. Quest knock. Did I get it right that time? Quest knock. I'm from New Mexico, so my first thought was, oh, that's okay. Quest knock. Cool. I'm gonna try and remember that. Welcome aboard. We are trying to solve this puzzle here. I just woke up. I do wake up in code, so my brain is a little mushy right now. So feel free to laugh and let me know if you think I'm doing something horrible. I probably am. Okay, so the idea here is to count it if it's greater than, all right, we're actually gonna start the minimum at, not math, int, dot min value. And yeah, I'm gonna go ahead and start all the way at the left and go with it. But tallest is gonna update to be equal to math.max of tallest, and the tree we're looking at now, current. So we'll create a variable here, current equals height map at row column. So we're gonna update that. I guess we don't have to do it all the time, and then we're just gonna say if current is greater than tallest, we're gonna add it to our visible trees. Dot add this row and column. And then I guess technically I can toss this in there since tallest is now gonna be current. All right, so I think that's gonna get from left to right. Go ahead and mark all my trees. And then I gotta go the other direction. The other direction is like this, where we start at size -1 greater than or equal to 0. I never write loops this way. I always tell my students to avoid for loops like this, but we're gonna do it. We're gonna break the law here. Right to left, starting at the rightmost column, moving our way left, pulling out our value from our height map, checking if it is greater. If it is, we add in that row and column and update tallest. All right, so that's left to right, right to left. And then let's do top to bottom. So now we're gonna do for int column equals 0, column less than size, column plus plus. And then we're gonna do it this way. I hate this. I hate writing this code. It's so gnarly. All right, then we're gonna go top to bottom and then bottom to because this will go top down. All right, bottom to top. All right. All this copy and pasted code is making me sad. But it's essentially the pattern we're using here. We'll do int tallest equals int.min, and then we'll reset that here. This I should absolutely be abstracting to a method. I should do that right now. I already hate myself for doing this. Yikes. I'm gonna abstract that. I hate that so much. And then let's go see which trees are visible, because in our visible trees, for each, let's just verify int location position in our visible trees, console right. Ooh, can I do this even better? Console right line string dot join visible trees, and then we'll print out console dot right line visible trees dot count. Let's take a look here, see what we get. $21, was that the correct answer? Okay, that gives me some confidence there. That if I were to give it my big input, my full input here, let's switch to input.txt. How do we do? 1543, as good a guess as any, I suppose. Hey, got a gold star. All right, let's clean this up, because this is nasty. This is nasty. All this copy pasted code. I'm gonna write a little function that will do that for us. So I want to abstract at the very least this chunk here. So it is gonna find the new tallest. Check tallest. Thank you for the gold star, Smab. Check tallest is a function. Questnock says, yay, I had the result for example correct, but not for the real puzzle. Now I'm stuck. Oh, that's a bummer. Oh, read the next bit first before I optimize this. Well, I just hate these loops. I hate these loops. I want to wrap it nicely in a part one. I know. But I want to wrap it nicely just for part one, because I hate myself for writing all this code already. Well, maybe you're right. All right, let me read it. Content with the amount of tree cover available, the elves just need to know the best spot to build their tree house. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, and right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under construction. The tree is right on the edge, at least one of its viewing distances will be 0. The elves don't care about, the elves don't care about distant trees taller than those found by the rule above. The proposed treehouse has large eaves. What's an eaves? Let's look at that. Oh. To keep it dry, so they wouldn't be able to see higher than the treehouse anyway. In the example above, consider the middle 5 in the second row. Looking up, its view is not blocked. It can see one tree of height 3. Looking left, its view is blocked immediately by a 5. It can only see one tree of height 5. Okay. Looking right, its view is not blocked. It can see 2 trees, 1 and 2. Looking down, its view is blocked. Eventually, it can see 2 trees, 1 of height 3, 1 of height 5. A tree's scenic score is found by multiplying together its viewing distance in each of the 4 directions. For this tree, this is 4, found by multiplying 1 times 1 times 2 times 2. However, you can do even better. Consider a tree of height 5 in the middle here. Looking up, it is blocked. Its view is blocked at 2 trees by another tree with a height 5. So 1, 2. So it counts. All right, so you count the tree, the first tree that is the same height or greater counts as a tree, a view score in that direction. Looking left, its view is not blocked. You can see 2 trees. Okay. Looking down, the view is also not blocked. You can see 1. Looking right, its view is blocked at 2 trees, 4, 9. And then we multiply together for 8. What is the highest scenic score for any tree? Ooh, this is fun. This is fun. This, I can solve this using recursion. I can solve this using recursion. Maybe I shouldn't. So we are trying to calculate the scenic score for each tree in our grid, and then you have to find the maximum one. And so a tree's score is defined as the number of trees it can see in each direction. So it has a view distance in north, east, south, and west, and then you multiply those together. So you can think of a view score, the way I'm going to approach this, you can think of a view score to the north is equal to 1 plus the view score to the north of the tree right above you. All right, so we need to calculate our view score for each direction, given a position, calculate the view score for each direction, and then multiply those together. Yeah. And so we can essentially, the naive thing would be like go to each one and calculate it. That feels slow. I'm gonna do a semi-smart solution. Semi-smart. I'm not saying it's the smart solution, but I'm gonna try and be a little efficient here, recognizing that my view score in a particular direction happens to be 1 plus the view score in that direction for that tree. So I think I can just like sort of recursively define that and blow up my stack and then go back to a naive approach. But yeah, we'll memoize it so that we have a quick lookup if we need to. I like it. Okay. All right. I was gonna try and still want to clean this code up here. But let's get part 2 and then we'll come back to it. Void part 1. Smab, I'm naive. Well, I mean, I gotta do something there. My thought, okay, so Smab, you're making it sound like the naive solution can finish. Part of me feels like this is, I guess it's pretty small data set. I was thinking this data set. Yeah, I'm gonna go for the O of N solution where you only have to look at each tree at most once. That's what I want to do. There's another solution. What would it be? You could sort of go around the outside. Is that right? You started on the outside. Anyway, maybe I should do the naive version first and then optimize, right? That's what they always say to do. Let's switch back to our example here. I don't need to print my height map anymore. We still have this visible trees as part of this solution. Size, let's make this a const. Oh, can I not make that a const? What are the rules? The expression assigned to size must be constant. Okay. You do you. Oh, I will. I will do me. Let me make it read only? No. Have my height map, I got my size, and now let me think through this. Oh, I shouldn't have renamed that without doing it this way. Okay. All right, let me think here. What am I gonna do? I want to calculate the up score. Okay, I don't even need, I'm not gonna do it recursively. I thought I'd do it recursively, but I'm gonna calculate the score to view up. I'm just gonna start from the top and move my way down and sort of be like, oh, well, you can do it that way. All right, so we'll do part 2. And yeah, so what do I want to do here? I am gonna have I'm gonna create a record type real quick, just for funsies. This is gonna be view scores dot, and the record is just gonna be, oh, I think I want to be able to, essentially I want to have a triple, but I want to be able to update it. I'm seeing something on my face that I don't like. All right, sorry to call it to attention. Public, I'm gonna make this a class, and I'm gonna do some bad programming here. Public, we'll do record. We'll try not to be terrible. View score, and we have view score in every direction. Int top, int right, int bottom, int left. So every tree is going to have a view score, and this is going to keep track of their score in a specific direction. Let's make this will be immutable. It'll be more efficient if it's mutable. Oh man, am I over engineering this? Let's over engineer it. Class tree. 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 Is tree in already a class somewhere? Tree. No. Okay. Let's rename this tree. All right. And this is just going to be a dumb holder for our own height. Hang on. Massaging my brain here. I'm waking up. I'm trying to problem solve. Essentially, I want to keep track of every tree. Am I overthinking this? So I'm trying to think of a solution that's going to make sense to my students as well. Let's go with a record, a view scores record. I liked that a little bit better. All right. we'll do this, then we'll decide if it's dumb. View scores, and we're gonna have four values in this record. 4 values in this record. We're gonna have, and come on, make that a little bigger here. We're gonna have int north, int east, int south, int west. That's what I'm gonna call it. All right, so this is our view score in each direction. And then given a view score, we can calculate our scenic score. So then we'll have public int scenic score is equal to north times east times south times west. Okay, this should be a get like that. Okay, so with view scores, we should be able to do that. And the idea is I'm gonna have a dictionary from each position. This is why I almost made a class. It's like, well, a class tree should have this thing to view scores. Like that. Pair. Hang on. What am I? Pair position to our view scores. Scores. Okay. Add in a row height. So row column to this. Every tree is going to have one. And so we're going to go ahead and calculate that. Starting from the, we'll go across and calculate our left score. So our west score. So for int row, you should totally, I mean, you should get some sleeps, man. That's what you should do. But I won't stop you from refactoring your code. I always say refactoring is a great way to go back and massage your brain. I want to refactor this already. I'm hating it. I want to get, all right. Hang on, here, can I do an here's what I want. I want a helper method. IEnumerable. I want a method here. It's gonna return something. I'm pretty sure I want to do IEnumerable, or is it IEnumerator? Int row, int column, get rows. All right, so I want something like this. And is it like a return yield? Return yield, is this 0, 0? Yield return? Is it yield return? Okay. Really need to document these and make myself a cheat sheet. So so this is gonna be get left to right, west to east. All right, and it's gonna go for int row equals 0. Row is less than size, row plus plus. For int column equals 0, column less than size, column plus plus. Yield return row column. So this will get my left to right. And I have, so when I'm doing stuff in Unity, I have a whole library for my Unity stuff for that exact reason. To west. Column equals size. like that. Size is greater than or equal to 0. Ooh, almost have a mistake here. -1. Column minus. And we'll do our top. So I don't have to keep rewriting this. Top. Oh, let me get rid of my get here. Sorry about that. Keith, I know Keith doesn't like that. Top to bottom. Top, we'll go column, row, top to bottom, and then one more. Bottom to top, which should be reverse here. -1. Row minus. Okay, so now we have these enumerators we can use that will make our actual code a little bit cleaner. Yeah, so we'll do for each int row, int column, in west to east. So now I can do this. We're gonna go west to east. We're gonna calculate it here. We know we start at the top one there. And I guess I should go ahead and initialize my border and start on the inside. So we have a special case if column, well, we just have a special case here. We're gonna say if column is equal to 0. So if we're in the leftmost column, the view score needs to get updated for our element. So what's interesting is this is what the west to east, since it's the first one, we're actually going to initialize it as we go here. So for the leftmost, we're going to do scores at, I can actually do position here. That might be confusing. At row column is equal to a new view scores. And we're going to initialize all these to 0. And the idea is at the end of this section, at the end of all these loops, these will be the correct values. But the leftmost one sort of gets initialized to that. Else, we need to check and see if we're blocked by the left side. So if, so if we're not in column 0, we want to get the height of the tree to our left. So height map of row column -1. So this is a tree to our left. If it's greater than or equal to our height map of us, and I'll pull this out here, int height, current height is equal to height map at row column. So if the tree to our left is greater than or equal to, and did I get that definition correct real quick? Sorry, I'm jumping around. If we're at the top, do we actually have a score of 0? If a tree is right on the edge, at least one of its viewing distances will be 0. Okay, so it's 0. I just wanted to make sure. So our height map, the thing to our left, if it's greater than or equal to our current height, then our score needs to get initialized to be, so So we have north. This is going east is 0. This is our west score. So the score to our left is going to be 1 because the tree to our left is blocking our view so we can see one tree. Else, so we have this case here. This is the case where the tree does not block our view. And so we can say that our score for our row column is going to be a view score 0, 0, 0. It's one tree, so it's 1 plus the view of the tree to our left, which happens to be like that. All right, so going left to right, we calculate our view score that way. Basically saying our view is equal to the sum, equal to 1 if we can't see past tree. Otherwise, it's whatever that tree's score was plus that tree. All right, so this is a little bit better. I'm about to write another for each that does this, but now is doing it for different directions. So I want to generalize this. I kind of want to generalize this to say calculate based off of a direction. So yeah, because otherwise I'm going to be writing these ifs. So this is going to be the same thing for left to right, right to left, top to bottom, bottom to top, except the offset is going to change slightly. The offset direction is going to change slightly. Yeah. And then which value we're writing into changes slightly. How we're modifying this value will change. Okay, so I'm gonna see if I can generalize that. So the things I need here, so we're gonna try, this is gonna return a view score. Calculate view score. And we're gonna have to have a row and column to calc, and then we're gonna have another one, an int row column, int column. So this is to calc. This is gonna be our neighbor position, like that. Ooh, maybe even we could do calculate view score. We need to get our neighbor, or should it be a function? Yeah. Maybe it's a function that takes in a position and calculates our neighbor. I'm totally overcomplicating this for the sake of not having to write a bunch of for loops here. So if we know our neighbor, then we're also gonna need our scores. Like this. Let's see if we can do this a little bit cleaner. Definitely overcomplicating it, but the code at the end will maybe be more readable. I don't know. Might actually be less readable. To calc neighbor is what essentially, this one becomes a little bit troublesome because we don't, so we essentially need a predicate that says if it's the first thing, right? So maybe we have this taken a function int bool is first. Int, oh, this is getting stupid complicated, right? Int, if it is first, all right. I'm abandoning that for now. We're gonna do this again, just so we can get a better idea of what it is. East to west. So we went left to right, now we're going right to left. If column is equal to size minus 1, we're gonna initialize our score. So our east value is gonna be 1, and then we have to still the values from the previous view scores. This is why I was thinking view scores might do better as a class, because I want to be able to modify these. Let's change this to a class. I want a way to, public, and then we're gonna have public north, public int north get set. We'll do that for each one of these. North, east, south, west. This dot north equals north. For good practice, these should be lowercase, like so. This dot east equals east. This dot south equals south. This dot west equals west. Okay. So now I can just modify that value. So they get initialized once, and now I can just modify it. So I can say that my east to west, so my east score equals 0. Otherwise, my east score is equal to 1. Otherwise, my east score is equal to my neighbor. Oh, there's a bug here. There's a bug here. This should be scores at row column -1 dot west. Should have written a test. I would have caught that with a test. So this becomes east is equal to 1 plus the tree to my east, which is +1 here. And the height to my east is +1. Okay. So this one initializes it. And if I'd gone through and initialized them all to begin with, I don't think I'd have to worry too much about this. So let's do that real quick. Int row, int call, position in west to east. We'll be slightly inefficient here. And we'll do scores at position equal to new view scores. And I'll add in a default constructor for this that just sets everything to 0. In fact, I don't need that. If I just do 0. And I really don't even need this 0 here because that's the default value for an integer. So I'll construct my view scores this way. And then here, I just update it. This one happens to be west equals 0. So now I'm seeing my generalized pattern. West equals 1. And this should be west equals 1 plus the score there that was previously there. Okay, so this is essentially my pattern. I need a selector for getting the left tree. I need to be able to determine if it is on the edge in that direction. A selector for getting the thing that was before this one, and then a way to identify that. So I could write some higher order functions to do this. I'm gonna keep doing it this way for now. So we've got north, or top to bottom. Let me rename this north to south, south to north, north to south. So if I'm coming from the north, if my row is equal to 0, my north gets set to 0. If the row that came before me happens to be greater than my current height, my north becomes 1. And if there's no tree blocking my view, my north becomes 1 plus the north value of the tree above me. Okay. And I'm gonna see if I can just generalize this a little bit. So I'm gonna do var is first is going to be a function of int row, int column, which returns column equals 0. Okay. Var get var prev is going to be, again, int row, int column goes to scores at row column dot west, and then var prev height. All right, so we'll call this prev score and prev height equals int row, int col goes to height map of row column. And this should be prev score column -1, column -1. So the idea is I should be able to substitute in here is first on my row column. Interesting. On my, no, not a pair, row column. So if it is first, and then this would be prev height row column. And I could even move this whole predicate in there. That's what I think I want to do. I'm going to change this to blocks is blocked, which is going to become greater than or equal to height map at row column. And then, so now I can just do is blocked here on my row column. And then finally, this west is still a slight problem. So we need one more thing called set score or update score, which is going to take in a view score score and an int value, and it's this, in this case it's going to be score.west equals val, and that becomes, yeah, each one of these becomes update score scores comma 0. This one becomes update score comma 1, and this one becomes update score 1 plus prev score row column, like that. So this is the abstracted version. So now I can, so my function that I'm gonna write has to do all of these things, which is a little bit gnarly. It's almost like I want a subclass. I want a class where I can pass these in and just do my run over them. So then for each one of these things below, they change slightly. So this becomes column is equal to size minus 1. I don't even need to get the current height here anymore. Size minus 1. Then we have is blocked column plus 1. This becomes column plus 1 dot east. This becomes score east dot val. Yeah, so these are my scores here, and then I can just use this same logic. I'm gonna pull this out into a method. Yeah. All right, so I'm gonna pull that out into a method. Void perform updates, and this has to take in all of those things. So this is gonna have to take in this is a func int bool. This is a func int bool. This is a func int, and this is a func view scores to, this is just an action, view scores int. This one's just an action because it doesn't return anything. And so my inputs become this to this method. Whew. That was this is essentially how you define an abstract-esque class in I guess you might call this a interface. This is essentially an interface that has these functions, and now I've sort of put it in as like a method call. So I kind of hate it. Perform updates, and I put I need to know the order in which I do my updates. So then I'm gonna do an I enumerable like this type. Order. I hate it. I hate this all. For each int row, int column, in order. Do this. Oh, and I still need my scores passed in there. Can I make it so I don't need scores? So update, rather than taking a view score, let's make this take a position. Int. This is horrible. Int row, int column, and we will do scores at row column like that, and this just becomes update score row column, update score row column, update score row column. All right, let's kill these real quick. And so this becomes int like that. Let's put this back in here like this. Whew. All right, that was horrific. If you watched all that, I am sorry. This is a ridiculously kind of a functional way to approach this. I hate it though, but the idea here is now I can just call perform updates with is first, is blocked, rev score, update score, and then west to east like this, which is, to look at, is a little nicer, but then you have to go in here and be like, what the F is going on? What the heck? All right, so we do east to west, and now we still have to redefine each one of these pieces. Really, I should have made this, this is almost more work. This is essentially more work than, oh man, this is absolutely more work than if we had just done our loops. And it's not even that much cleaner. Oh man. Whew. And this should go east. I suppose it is slightly more testable. That is one thing about what I've done here, is it is a little bit more testable. Update score. This should get our east. We're setting our east value, so we go east to west. Yikes. As a abstract class, not even abstract, yeah, I think abstract class would be the way to go. Yeah, abstract class, we want an abstract function, and then your subclass defines these things. That's the way to do it, to make it not so horrible. Then let's go north to south, south to north. And for clarity, I suppose I could abstract these into functions, but if I was in Haskell, this is essentially kind of how I do it in Haskell. I define a type class that has these, and then define how it should happen over each direction. So top to bottom, if row happens to be 0, we're gonna do row minus 1. Score minus 1 north. This would be yeah, link's gonna slow you down a little bit there. Honestly, I should have done the naive thing here to get the right answer first and then refactor, because I actually don't even know if I'm coding the right thing before all of this refactoring. Update score, this is gonna be north. And then for my south to north here, it happens to be size -1, +1, +1 south, and south. Whew. All right, let's see. I should have been running. I haven't run my program, and my students, if any of my students happen to see this, they're gonna yell at me. So I always say, when was the last time you ran your code? All right, so my program doesn't crash, which gives me a little bit of confidence that I've built up my view scores. All right, so we're gonna go with a, we're gonna write a function. We're gonna pull this into a function here. Calculate view scores. And this will return scores at the end of it. And so now, once we have our view scores, view scores, scores equals calculate view scores, we just find the max scores dot max. Can I put a transformation in here? I think I gotta do a select first. Select S goes to values. Hang on. Values dot select S S dot scenic score, and then we find the max. Int max equals console dot write line. The max scenic score was max. All right, cross your fingers for me, because I've written an awful lot of score. 8. All right, I have a little bit of confidence. The example works. The example works. All right. $108. Oh no. Oh boy. Let's. All right. All right. Very sad here. Hang on. Oh, I thought I saw it. I thought I saw it. Oh boy. All right, we're gonna have to break this out into functions and see if we can find where something is going wrong. This is where a test would be really nice. Yeah. Okay, so we're gonna do calculating left to right. Let's see if we can find our mistake here. So void calc west to east. right, let's go to our small example and see if we can figure out what our west to east score should be at this point. All right, so let's return. I want to take a look after I've done this. I want to make sure my west values are what I expect. Yeah. So I need to print. I want a nice way to print my dictionary. So let's do it. Let's write a void print. I guess I could write an actual test here. Void print dictionary. Print scores. And this is gonna take in one of these. I'm gonna loop through for int row equals 0, row less than size, row plus plus. So we're gonna do each row for int column equals 0. I just want it to be in order. Otherwise I just iterate through this whole thing. So in fact, I can do west to east for each int row, int column, position in west to east. So this will get me top left and just go across here. And I sort of want to print out my values, console. Well, I want to do it in a nicer way. All right, we're gonna go back to the way I was gonna loop through it, because that's what I want, just so I can eyeball it a little better. Column less than size, column plus plus, console.write line, console.write, we're gonna write our scores row column. I should probably be using like a printf to make it take up a certain number of space. I want each one to take up a few columns. Someone help me out. What's the formatter here? Can I do a formatter on this that's like 3, 3? Will that make it take up 3 spaces? Let's try it. We'll do our print scores here. And the scores, oh, it's not quite right. Scores dot, after we've gone west to east, we should have all of our west scores completed. So we are gonna, at this point, call print scores. So I just want to examine my west scores, and then we will end there, return scores, and not do anything else. There we go. All right, so just using this example, I know I should have 0. See if I can find my bug in my simple example here first. 0, 1. So that one makes sense. Everything to the left should be 1. 2, 3, 1. That makes sense. 1, 1, 1, 2. That one makes sense. 1, 1, 1, 1, 1, 2, 1, 2. Oh, Oh, I see the error I've made. Oh, dang. I can't do this recursively because if this one is taller than that 5, is that right? Can it see the 3? I think I just misread the problem. I've solved a problem that's different. Each tree... All right, let's look at puzzle 2. The elves don't care about distant trees taller than those found by the rules above the proposed tree. Eaves in this example. Yeah, I think I've misread the problem. I just didn't... I'm solving a different problem. Because looking up... Let's read here. Let's see if we can find... Yeah, so this 5 to the left, its view is not blocked and see 2 trees, but the way I've calculated this 3 would be blocking that 3 from this 5. So I've just calculated the completely wrong value here. Oh, that's sad. All right, well, easy to detect, I suppose. So I just misread the problem. I didn't understand it well, and I tried to be clever. And that failed me. Yeah. Well, darn. Okay. So can I salvage this? Can I salvage this? I think I can. So we check is blocked. Can I change the way is block is defined? We want everything that came before it. We want to find the first thing that came. We want to count before it the first thing that's larger than it. So I guess I am going to write a slowish solution, which is disappointing. Okay. I've said okay a lot here. That's my way of coping. It's my coping word. It's going to be okay. All right, so here's what I'm gonna do. The perform updates, I'm gonna keep as we're moving, I'm gonna try something here where I'm gonna keep a list in order of previous heights, prev heights, like this. And so we're gonna actually, after we have done this one, we add it to a previous. So it'd be order dot add, sorry, prev heights dot add height map of row column. So these are our previous heights. So if it's the first one, we set it to 0. Otherwise, we find how many things, how far we go back before we match it. All right, so else we need to look at all the things to the left of us. So we want to iterate over this in reverse order. So maybe if I made it a stack, then I just get my, hang on, let's make it a stack like this. And then I'm not gonna stack, and we'll just push these on because we want them to be most recent. All right. And then we are gonna do stack. We're gonna do our prev height dot take while. We're gonna take it while our height. So take while, here, let's do this. Tree height. We'll pull it out here. Int tree height equals. So take while other. And we're gonna do tree height. Well, other, let's see. We want to take them while they are less than, ooh, but we want to stop when we get that first one. It's a little tricky. So tree height, take while the tree height is greater than, this predicate's annoying. Because we don't want, there's multiples. The first time we find a tree that's our same height, we can't see past it. But we may not have one here. All right, I'm gonna write it in an iterative way here. Let's turn this to a list real quick. And then I'll see if I can do the link to list. For each int other height in this int view equals 1 view plus, and then we're going to say if so we always increase our view by 1 when we see a tree, but then we're going to say if other height is greater than or equal to our height, we break. So the first time we see a tree bigger than us, we break. And then we do update score of our row column with view. All right, so I don't need prev or is blocked, which is nice. But is forced, update score, and order should still do it here. All right, let's check the test here. Let's comment all this out. Well, that's not correct for sure. What is going on there? What is that? That is, if the other tree height is greater than to our current, should we break? Each row, our previous heights needs to reset. Is first. All right, so whenever we have an is first, prev heights gets dumped. Prev heights dot empty clear. All right, we dump it each time. Okay, this looks better. This looks better. We have 0, 1, 2, 3, 1. We have 0, 1, 1, 1, 2. We have 0, 1, 1, 1, 1. We have 0, 1, 2, 1, 4. All right. I feel confident. I feel much more confident with this. Okay. So we have we don't need prev score or blocked. Instead, we need first and update score. And that makes this quite a bit nicer looking. Okay. Well, let me not celebrate yet. I did find my bug. I misread the problem, but let's not celebrate just yet. I need to still check if it works here. Got our example, part 2 here. Was giving me 8 before. All right, still got 8. Let's run it. That number looks big. That can't be right. That, oh, well, it's a multiplied number. It can be right. I was thinking it was like the sum of trees or something. Okay. Hey, hey! There we go. Got my second gold star. Second gold star. This one's cool. This one's cool. I'd love to do a heat map of the view, right? Okay, and I'm much happier. Perform updates is a terrible name here. But I am glad that I was able to sort of abstract it a little bit here. Smab, thank you for sharing yours. Let's take a look at what we got here. Let's take a look. I've got about 20 minutes before I gotta hop off here, but let's take a look. Solution 1. Is this 2D array? Is that just built in? Or is that a helper that you've added? Can we just do 2D array? I'm assuming you have an extension method. Okay, I was like, well, that's a new thing. Nice extension. So we convert it into a 2-dimensional array. We have the width and height. Okay. If it is visible, we increase it. How does your is visible work? We are visible if we're on the edge of the grid. Otherwise, we check each direction. Okay, so you went with the sort of what I would call the naive approach, right? Where we loop through, we essentially, for every position, just check if it's visible in each direction. So this is like the n² solution, which is fine. It's just fine. I went for the slightly more efficient O of n solution. But this is nice. This is what I'm going to suggest my students do. I'm going to tell them, all right, so we want to figure out if we're visible in a direction and just sort of go out that way. And then I'll say, well, and then turns out there's like a slightly more efficient way to do this, but the code kind of ends up being a little bit gross. Okay. And is visible in the directions. Not too bad. This while here is a little bit gnarly, in my opinion. It's a little gnarly, but not the worst. If we're not -1, because we're basically checking for bounds here, right? That makes sense. Check the bounds and then increment in the direction we're going. Perfect. And if we happen to get to the end, then we're true. If we find something where it's not true, we return false. Not bad. All right, part 2. Let's look here at part 2. Same thing. We get our input into a 2-dimensional array, and then we just calculate our scenic score for an XY. Loop through all positions, calculate the scenic score, and pull it out. And you've done again the solution where it's sort of at the end. I think it's n squared or n times. It's at least an n times m. I think in the worst case scenario, it's n squared because might be, yeah. Viewing distance, we go out in each direction, so we have to check all of the positions relative to n. So some kind of n squared. Fine, this is great. This is a nice naive solution. Naive is the wrong word. This is the straightforward solution. This is the straightforward solution. My solution, I was trying to be more clever in that regard. Is it that much slower though? Like how long does this take to run? So let me ask that. How long does this take to run on your big input? My solution is, I think, I don't know how to really time stuff here. Do I have a time? Time.net run. I think this is also gonna have to like build. Mine's 1 second, almost 2 seconds. So I'd be curious how fast yours is on the part 2 version. So not even that slow. The one thing though is as the size gets bigger, your giant set will become very the solution, the search space just gets bigger and bigger. It's not even a search space, just bigger and bigger. Okay, not bad. That's fine. It's essentially, you know, for the problem size, the size of input, it wasn't even really worth it to write it this quote unquote clever way. Oh, actually my way is not even clever. It's not even that clever. I have, yeah. I still have, in the worst case scenario, a tree all the way on the left. Let's say that you could set it up. Yeah, so there's not really a good solution here. I think, I'm trying to think, there is probably a solution where you sort of, you could start, could you do a thing where you spiral from the outside in? Yeah. Oh, you sent a second one. Sorry. I didn't even see that second one. I got distracted. I became deep in thought on, can we solve this in a better, more efficient way? If we sort of start on the outside and shrink our way in, saying, okay, well, we're going to go around the outside. There's some calculation that we can make. So we know the outside scenic scores and we move in. And that's sort of what I've done, but I've gone bottom, up, left, right, right, left, and top, bottom. But there's probably some clever way to do it where you sort of spiral in, calculating as you go. Is this the right link? Oh, this is your ongoing refactor. Gotcha. Okay, so count where they are visible. And visible, you've created a thing called cardinal directions, which I'm assuming is the orthogonal directions. And it passes those in as a pair here. Yep. You might be able to do something with a range here. I don't know for sure. But this feels like something that an enumerable would be nice. So you could have a function that, given a direction, produces an iterator that just sort of goes in that direction. And then you can do sort of so I was just, my suggestion here was potentially to use some sort of enumerable that basically chunks through your starting position and just updates it, and then you have sort of a linky thing you can do there where you sort of get it and then you take while such and such thing. It's too slow. Bummer. I'm surprised it's so much slower. Gotcha. All right, this is I like your solution essentially better than mine. My solution just sort of blew up out of control here, but I'm gonna have in my strategy video, I'm going to use essentially what you're doing here, whereas you have a function given an XY position, can you calculate the score for that thing? And that's just going to be, and I'm going to state, here is a straightforward approach. It's not the most efficient, but it's super straightforward. All right, nice. Thank you again for sharing, Smab. You should go get some sleep. I know you're dying. Let's take a look here. Well, the history on... Oh, this is a gist? Well, I don't see... Oh, solved. Okay. Let's browse here. Gotcha. Yeah, it's not bad. Ooh. Things get a little gnarly in here. Hey, this looks like my code. Scenic score. Yeah, it looks just like mine there. I was not proud of going, well, and I almost refactored this and then you guys stopped me. You said, don't do it. And so I didn't. All right. It's been fun. I've enjoyed this very much. Fun puzzle today. I like having to use my brain a little bit rather than just being like, oh, I'm going to engineer this thing. Trying to come up with a nice solution. I was a little sad. I'm gonna have to think through it. Maybe I'll look at some other solutions, but yeah, what's imperative programming? Just send them all these loops. I tried here. Perform updates is a terrible name for this, but I sort of abstracted it. What I should do in this case is, if I was doing the quote unquote object oriented way, I'd use a strategy pattern. So I'd implement a strategy pattern called left to right, or I'd call like iterate pattern, iterate strategy, or like calculate strategy, and then have this be a method defined in an abstract class, and then these three things would be the abstract things that you need to implement in the subclass. Oh yeah, I know. Object-oriented programming didn't come out until like essentially didn't get popular until the 90s, I believe, with C++. I started programming in the 90s, but I've actually done some stuff with Fortran. which is fun. Fortran's fascinating little programming language if you use some other languages in the past. Smab, you might have used Fortran as well. Fortran is just it's a different way of thinking. There's no stack, so there's no. That's not entirely true. There's essentially no. The one thing that I found most interesting about Fortran is that Fortran doesn't have recursion. At least the version of Fortran I use, I like Fortran 88 or something. I'm not sure. I love Lisp. Maybe not Lisp, but I love Scheme, which is essentially Lisp inspired, which is now called Racket. I've done a lot in a programming language called Racket / Scheme. Lots of parentheses. People usually hate it, but if you like Lisp, Scheme is good. I've never used Smalltalk, but I've read about it quite a bit. I wouldn't call Fortran hard. I'd call Fortran different. It's a different. You gotta start thinking, how does Fortran do it? Ooh, nice. Linking Fortran to C. I also love C. C is really fun. I wish I got to program in C more. I really want to have I just never quite get there. I always want to do system architectures, but my students always. I'm not teaching at the college level. I do tutor some people at college level now, so I've done a lot of like system architecture tutoring. I would love to design, or not even design, but just teach a class that is sort of system architecture in C, and have my students implement an operating system or parts of an operating system in assembly in C. All right, well, I'm about to hop off here. If you would like to see more Advent of Code, I've been streaming every day. I don't know if I'm going to stream every day, but if you're new here, be sure to follow to get notified when I'm doing puzzle number 9, probably tomorrow morning. Prototype graphical interface before Windows. Nice. What operating system are you using? I've done, PDP. I worked on PDT in other Unix systems before as well. I remember before you could get segmentation faults. You'd be just writing into memory and suddenly your screen would get all crazy because you went outside of your program space. That was one of the funniest. That's something that my students will never get to experience unless they go out of their way to do it. But programming in an operating system that doesn't segment your processes and you can just write into memory anywhere you want. Maybe I should have students program on a Commodore 64, because you can do that on Commodore 64, peek and poke anywhere in memory, which is fun to do. All right, I'm heading out. It was so much fun today chatting with you. I'm glad we got through it. I will see you next time. Get some sleep. Have a beautiful day. And we'll see you next time.